Today let us consider 1-mark questions. Consider the first question. Give an example of a relation which is symmetric only. For this, let us consider a relation R defined like this. It is a set containing ordered pairs of the form A, B such that A is perpendicular to B. This relation R is symmetric only because if you consider the ordered pair A, B where A is perpendicular to B, this also implies B is perpendicular to A. This is not reflexive because if we consider the ordered pairs of the form A belongs to R, that means A is perpendicular to A, but this is not possible. Therefore, the relation R is not reflexive. It is not transitive because if we consider the ordered pair A, B belongs to R and B, C also belongs to R, that implies A is perpendicular to B and B is perpendicular to C. For example, the line A, if it is perpendicular to B and if this line B is perpendicular to C, then A cannot be perpendicular to C. Therefore, the relation R is not transitive also. Now move on to the second question. Find the principal value of cos inverse of minus 1 by root 2. Let us consider y is equal to cos inverse of minus 1 by root 2. But we know that cos inverse of minus x is equal to pi minus cos inverse x. So if we use this property, the given function can also be written as y is equal to pi minus cos inverse of 1 by root 2. And we know that cos pi by 4 is 1 by root 2. Therefore, this is pi minus pi by 4. Therefore, if we take 4 as the LCM, this becomes 4 pi minus pi, that is 3 pi by 4. Therefore, the required principal value is equal to 3 pi by 4. Now let us move on to the next question. Construct a 2 cross 2 matrix A equal to Aij whose elements are given by Aij equal to 2i plus j. Let us consider a matrix A equal to Aij where I indicates row and j indicates the column position of the element. We have to construct a matrix of order 2 cross 2. So, let us consider A11, that is, according to the statement, Aij is 2i plus j. Now it is A11 means I equal to 1 and j equal to 1. If we substitute these values here, we'll get 2 plus 1, that is 3. Consider A12, that is I is 1, j is 2. If we substitute these values in the function, we'll get 2 plus 2, that is 4. Consider A21 equal to I is 2 now, j is 1. So 2 into 2, 4 plus 1, that is 5. And finally, let us consider A22. I is 2, j is 2. So 2 2s are 4 plus 2, that is 6. Therefore, the required matrix A is equal to, it is A11, A12, A21, A22. Can also be written as 3, 4, 5, 6. And this is the required 2 cross 2 matrix. Now move on to the next question. Y is equal to e to the power 3 log x. Show that dy by dx equal to 3x square. Let us consider the given function y is equal to e to the power 3 log x. This can also be written as e to the power, so this is of the form n log a, can also be written as log a to the power n. That means e to the power log of x cube. And we know that e to the power log of f of x is f of x itself. Therefore, the given function y is equal to x cube. Now, if we differentiate this, dy by dx is equal to derivative of x cube is 3x square. Now move on to the next question. Find the antiderivative of x square into 1 minus x square with respect to x. That means we have to find the integral value of x square into 1 minus 1 by x square. Since it is with respect to x, let us consider dx. Before integrating, let us multiply the function x square into 1, that is x square, minus x square into 1 by x square, so that x square get cancelled with this. The remaining value will be minus 1 dx. If we integrate this, integral of x square is x to the power 3 divided by 3 minus integral of 1 is x plus c, that is the constant of integration. Now move on to the next question. Find the unit vector in the direction of vector A equal to I cap plus j cap plus 2k cap. We know that unit vector of any vector A is denoted by vector A cap is vector A divided by magnitude of vector A. So, now it is given that vector A is equal to I cap plus j cap plus 2k cap. Therefore, unit vector of this is equal to the vector, that is I cap plus j cap plus 2k cap divided by its length. Its length is square root of I coefficient, that is 1, 1 square is 1, j coefficient that is also 1, so 1 square is 1, and k coefficient that is 2, 2 square is 4. So this can also be written as I cap by root 6, j cap by root 6 plus 2k cap by root 6, and this is the required unit vector of vector A. Now move on to the next question. Find the direction ratios of the line x minus 1 by 2 equal to 3y equal to 2z plus 3 by 4. We have the standard form x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. It is the equation of the line passing through the point x1, y1, z1 and parallel to the vector with direction ratios a, b, c. Now we have to find out the value of a, b and c. Consider the given expression, that is x minus 1 by 2 equal to 3y equal to 2z plus 3 divided by 4. First we have to convert this given line to the standard form. So x minus x1 by 2, keep this as it is. But here the coefficient of y, that is 3, that is to be removed. So we can write this as y by 1 by 3. And it is 2z plus 3 by 4. So the coefficient of z is 2, that is to be removed. So this can also be written as x minus 1 by 2 equal to y by 1 by 3 equal to z plus 3 by 2 divided by 2. Therefore, the required direction ratios are 2, 1 by 3 and 2. Now move on to the last question. Probability of E equal to 0.6 and probability of E intersection F equal to 0.2. Then find probability of F condition E. We know that probability of F condition E is equal to probability of F intersection E divided by probability of E. That is, probability of F intersection E, it is given 0.2 divided by probability of E, that is also given 0.6. So this is 2 by 6, that is 1 by 3.